Welcome back to the fourth part of my character kitbashing tutorial series. In this video, I'm going to be showing you how to add or replace extra items of clothing to your character. Let's start this video off by switching to the shader view and taking a look at the character's boots. As you can see, they're not really that high quality, and I'd rather replace them with something more detailed. Since we are kitbashing, we are not limited by any particular source when it comes to collecting 3D assets. For this demonstration, I'm going to be downloading these leather shoes by Chemprol, which can be found on Sketchfab. For those of you who don't know, Sketchfab is a 3D asset marketplace where you can find both free and paid assets to use in your own projects. I've put the link to these shoes in the description below. Once you have downloaded them, place the zip file into your Kitbash project folder and then extract it. Delete the zip folder, and then navigate over to the model and copy the URL. Back in Blender, go to Add-ons and make sure that the FBX add-on is activated. Now let's go to File, Import, and then select FBX. Paste the URL into the address bar and then import. It will be quite large when you first import it. Switch to a top-down view. We can see that the right shoe is aligned with the x-axis. We will only be using this shoe, so let's delete the other one. Go to Edit Mode. Phase select the entire left shoe and delete it. Return to Object Mode. Right-click the remaining shoe. Set Origin to Geometry and rotate it 90 degrees. Now right-click and set the origin to 3D cursor. Then select the Scale tool to resize the shoe so that it fits the character proportionately. Move it so that it overlaps with the original boot, and rotate it slightly so it aligns properly. Make sure the shoe fits. Now hide the original boots. Let's start by texturing the shoes. Click on the shoe, go to Materials, and then click New. Rename this material to Leather Shoes. Click on Shading Workspace. Bring up the Textures folder for the shoe. Drag and drop each JPEG texture into your node tree. Now that we have all our textures imported, we just need to connect them to the material. Grab the normal map texture and drag it over. Press Shift-A, search. Normal map, bring that node in, and set the normal map texture to non-color. Connect that color to the normal map node, then connect that node to the material menu. I'm going to explain a slight issue with importing Sketchfab textures. Blender's default materials are designed to work with OpenGL normal maps, while Sketchfab models commonly use DirectX normal maps, as many authors expect their models to be used with the Unreal Engine. DirectX projections appear to be inverted, while OpenGL projections are not, which makes them easier to read. If you ever have to use a DirectX normal map in Blender, all you have to do is simply invert the green color. To do this, Shift-A again, and add two nodes, Separate Color and Combine Color. Once you have brought them both in, connect all the colors together. Then add an Invert Color node. Drop that node on the green color's connection. You should now see the normal map projection on the shoe change. Make sure to clean up your nodes to remove visual clutter. Adjusting the invert color slider will allow you to switch between DirectX and OpenGL. Be sure to always check your imported assets for inverted normal maps. Now let's get back to the other textures. Next up is the roughness map. Set that to non-color and connect that to the roughness. Do the exact same process again for the metallic map. Now, for the base color and the ambient occlusion, we're going to mix these two textures together. Shift-A and bring in a mix node. Set the float to color. Then connect the base color texture to A and the AO texture to B. Set the mix node to multiply and then set the factor to 1. Then connect the multiply node to the base color. Go back to the layout workspace and click on the shoe. Then shift select the pants. Press Ctrl L and copy modifier. This will copy the character's armature modifier to the shoe, allowing the shoe to follow the character's skeleton. The shoe has no weight paint information, so it won't be able to flex with the character. As it was never part of a Kitbash pack to begin with, we would be working completely from scratch, unless we use this simple trick. There's a reason why we haven't deleted these boots yet, and that's because we're going to transfer the weight paint from the boots to the shoe. First, select the boots, then shift select the shoe. Go to Weight Paint, Weights, and then transfer weights. In the Transfer Mesh Data menu, set Source Layers to by name. Now you can see that the weight paint from the boots has been applied. Hide the boots again. You can see now how the weight paint has been applied to the shoe. We need to fix the weight paint on the toes because it was not properly applied. Go to Object Mode, click on the armature, click on the shoe, and then go to Weight Paint mode. Select each of these bones, and take a look at how the weight paint has been applied. You can see that the weight paint on the toes stretches too far back towards the heel. Select the gradient tool and set it to 0. Pull a gradient across so that the weight paint is brought closer to the toes. As the toe's pointing upwards, there's a small part of the shoe here that's protruding down. Go over to the ankle bone, set the weight paint gradient value to 1, and then drag another gradient across. That will fix the issue by smoothing out the bump. Let's go back to the toe bone again. Set the weight paint gradient back to 0, and sharpen this toe section a bit more. Let's do a posing test. The toe bone is affecting part of the pants, which we do not want. In order to fix this, we're going to first select the armature and then the pants. Go to Weight Paint mode, double-click on the toe. Drag a 0 gradient up. That will delete the unnecessary weight paint information. Let's go back to Object Mode, move the ankle bone around, and check for any more artifacts. When we are done, right-click and clear the user transforms to set everything back to the default position. We have now finished weight painting the shoe. We just need to duplicate it and move it over to the left leg. Not only do we have to move it over, but we also need to transfer the weight controls to the bones on the left leg. Let's start by duplicating this shoe. Select it and press Shift-D, and then press Escape to reset the position. Then right-click, go to Mirror, and then Mirror X Global. We're going to reveal the boots again, and match up the shoe placement with the left boot. Once they are matched up and perfectly overlapping, you can hide the boots. Now, I'm going to show you how to transfer control of the weight paint from the bones on the right leg to the left leg. In order to do that, first go to Data and then Vertex Groups. The Vertex Groups panel shows the weight paint stored for each object. Each line in this list corresponds to an individual bone within this armature. If you need to find an exact name of a bone, simply click on the armature, go to Pose Mode, and then click on a bone. Here, you can find the exact name of the bone you're looking for. Take note of that. Go back to Object Mode and go to Vertex Groups, where you will also be able to find that bone. Since we duplicated this shoe and mirrored it over from the right leg, all of the weight paint information we just created will be found within the right calf, foot, and toe. To reallocate the weight paints from the right foot to the left foot, all we need to do is delete the vertex groups for the bones on the left side. Delete the left calf, foot, and toe. Then we just need to rename our calf to L calf, our foot to L foot, and our toe to L toe. Now bones on the left leg can control the left shoe. The same weight paint issue that we had between the right shoe and the pants has persisted to the left shoe. In order to fix this issue again, we simply need to go to Object Mode, select the armature and the pants, go to Weight Paint mode. Double-click on the bone and then drag a 0 gradient upwards. Clear the user transform. Do a stress test on all the bones on the right leg, and then work your way up and then down the left leg. You will find some bones on top of each other. To select the other bone in the same location, simply click on the bone again. In case you're wondering what those bones are used for, they just make the fabric react to in-game physics, like wind. Once you're done testing and have found no issues, all we have to do now is combine these two shoes together. When joining two objects that have been duplicated and mirrored, you will notice a strange artifact. This is called flipped normals. It's quite subtle, but it can cause lighting issues. Select the left shoe and the right shoe, right-click, and join them. Looking back at the left shoe again, you will notice that the normal map on the left shoe has been flipped. When objects are mirrored, their appearance is inverted front to back. This will invert the object's faces, which flips its normal map. To see this more clearly, go to the top right corner, click the Overlay Icons drop-down menu, and go to Face Orientation. You will see that the shoe is red because its normals have been flipped. You will only notice this once the shoes have been joined. To fix this, go to Edit Mode, go to X-Ray Mode, and face select the red shoes mesh. Then go to Mesh, Normals, and Flip. This fixes the issue, as the shoe is now blue. You can now turn off face orientation. All we have to do now is rename these objects to leather shoes. That concludes part 4 of my character kitbashing tutorial series. In the next part, I'm going to be showing you how to edit the textures on these models to make them more realistic.